Predetermined. Made up. Yes. Suppose Brady earned an 86% on his statistics test. Should he be satisfied or disappointed with his performance? So what that means is relative to the rest of the class. Okay? Should he be satisfied? So did he do well, or was everybody like way above? So we have a little STEM chart right here. And what you want to do is count the number of people below Brady's score. So everybody in red, all right, and out of the total. So this lovely chart has 25 numbers, all right, and you'd count up all the ones in red, which are all below the 86, and there are 21 of them. And so 21 people scored below Brady out of 25, which means that 84% are below. And we call this a percentile, all right? So you might want to kind of make note. Brady scored at, that's how we say this, the 84th percentile. Okay, so percentile, you always want to count the number below. Okay, do not include the number below. And then that person scored at that percentile. So the definition of percentile, the pth percentile of the distribution is the value with p% of the observations less than it. Okay? So the value with p% of the observations less than it. So count the number below and divide by the total. So let's look at some other people's scores and see how they compared. Find the percentiles. All right, so Emma got a 72 on this test. So count up how many are below the 72. 1, 1. All right, there's only one below. Somebody got a 67. So one person's below the 72. So I have 1 out of 25. And so Emma scored at the 4th percentile. Okay. April, who scored a 93. How many are below the 93, you guys? 24 of them. And so April's in the 96th percentile. Nope. Yeah, that's how they do this. The two students who earned an 80%, how many are below the 80%? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are two 80%. You still just go below that. So I have 12 out of 25, which is the 48th percentile. Okay. All right, let's also talk about cumulative relative frequency graphs. And we're going to talk about the ages of the first 44 presidents when they took office. Okay. So, first 44 presidents, 2 of them were ages 40 to 44. And 7 were 45 to 49, etc. Okay. We're going to start by finding the relative frequency. So frequency, you guys, is just counts. What's relative frequency? Percents, okay? Change it into percents. How many presidents are there in this? There's a total of 44. It tells us right here. So for relative frequency, we have 2 out of 44 of our presidents who were young, and we get 4.5%, okay? And for the next one, we have 7 out of 44, which gives us 20. Nope, just kidding. 15.9, sorry, percent. And then we have 13 out of 44, which gives us 29.5%. And then we have 12 out of 44, which is 27.3%. And then 7 out of 44, which is 15.9%. And these old guys, 3 out of 44, 6.8%. All right, so now we're going to start doing cumulative. We're adding in cumulative frequency. This first one is just counts. Cumulative frequency. We add up all the previous ones. So for this first age group, we stick with 2 because there's nobody below it. All right, and for this next age group, we add. So cumulative, we're adding these. There are 9 who are 49 and below, okay, or below 50. And then we add our 13 to the next one. So plus 13 right here, and we get our 22. So there are 22 that are below 55. And then we add another 12 right here. So add 12. And there are 34 who are below 60. And then I'm going to add 7 to that, and there are 41 who are below 65. And then I'm going to add 3, and we get our total of 44 presidents. Okay? So we'll always add the previous number. And then we're going to do, of course, cumulative relative frequency. So cumulative frequency is counts, but we're adding them to the previous number. And then cumulative relative frequency is percent added together. So our first one is still 2 out of 44 because there's nothing to add to, and we get 4.5%. Then we would do 9 out of 44, or we can add these percents together right here, and we get 20.5%. Then you could do 22 out of 44, or add all your percents, but 22 out of 44 is a pretty nice percentage. 50, okay? And I think you guys got this, hopefully. Then it's 77.3, and the next percent is 93.2, and the next percent is 100. All 100 presidents are less than 70 years old, or 100% of presidents, how I should say it. Okay, we're going to make a cumulative relative frequency graph, also known as an ogive, which you should write this down because this is one of the words on your crossword puzzle. Good morning. It's called an ogive. Okay, so age at inauguration goes on the bottom. We're going from 40 to 70. So I'm going to go every 5 years down here. This would be 40, 45, 50, 55, 60, 65, 70. So you have to be able to read these graphs. Is the main thing. Cumulative relative frequency means it needs to go up to 100% because we're adding our percents on this. So go all the way up to 100. So I'm going to go by 20%, and then 40%, and then 60%, and 80%, up to 100. All right, these always start at 0, and they always end at 100. So 40 is actually going to start at 0, because this represents the percent of presidents that are under 40 years old, which was nobody. Okay. And then 45 represents the presidents who are under 45. So what percent of presidents were under 45 for relative cumulative frequency? 4.5%. All right? So you always go to the next one. This bracket really represents under 45. So when I go to 45, I'm putting 4.5% on here. Okay, 50 represents presidents under 50, cumulative. So that would be 20.5% who are under 50. We're adding all of them together. 9 of them are under 50. So 20.5%. Okay, 55 is the number under 55 percentage, and that was 50%. So I'm going to come up here to about 50. And the ones under 60 are 77.3. I'm going to go with about here. Ooh, I kind of missed. And 65, we've got 93.2% who are under 65. And everybody so far has been under 70, except for, how old is Trump, you guys? I don't even know. Really? Interesting. Okay. And then we connect our dots. And it should go all the way up, right, from 0 to 100. How old was wasn't Bernie Sanders like the oldest?
Yeah.
I think he was like pretty old. However, Obama was pretty young. So, was Barack Obama, who was first inaugurated at the age of 47, unusually young? So we're going to go to our graph. Okay, and I want to know 47 is about what percentile? So, you got to make a line. 47 is about right here. You go straight up, and you go straight over, and you estimate. Okay? My graph's not as good. The book says it's supposed to be 11%, but that kind of looks like 10-ish. But you get to estimate. There's not really a wrong answer. But I'm going to go with, you know, the book, 11th percentile. In other words, 11% were younger than Obama. So if 11% were younger, you guys, what percent are older? Yeah, 89% are older. Just put an arrow for up, so you're going to have a room. Now let's go the other way. So we started with age, and we found percentile. Now we're going to estimate and interpret the 65th percentile of the distribution. So if I want the 65th percentile, you got to go over here. This is 70, so this is maybe 65. Start with your percent and drop your straight line down. And that should be about 58. And that's an age now that we found. Okay, we started with percent, so now I'm going to an age. So estimate and interpret, be sure you do that, the 65th percentile. So that would be age 58. What does that mean? About 65% of U.S. presidents were younger than 58 when they took office. All right, well, multiple choice. Let's see if you guys got this. Select the best answer. Mark receives a score report detailing his performance on a statewide test. On the math section, Mark earned a raw score of 39, which placed him at the 68th percentile. This means that A, Mark did better than about 39% of the students who took the test. B, Mark did worse than about 39% of the students who took the test. What do you guys think? Does that 39% have anything to do with percentile? No, 39 was the raw score. We don't know what it's out of, right? C, Mark did better than 68% of the students who took the test, or Mark did worse than about 68% of the test, or E, Mark got fewer than half of the questions correct on this test. What do you guys think? Good, that is the definition of percentile. He did better than that lovely percentile. Okay. And we have our lovely, we've got call versus percent here, call length, all right? So about what percent of calls lasted less than 30 minutes? And then answer also 30 minutes or more. What percent of calls lasted less than 30 minutes? So you're going to start at the bottom on 30 minutes. You're going to go up right here, and you're going to go over. What do you guys think? What percent of call lasted less than 30 minutes? Yes, 65% of calls lasted less than 30 minutes. So how many lasted longer? What percent lasted longer? 35%. So if 65% is less, then 35% is more. All right, this is new, and you definitely want to know how to do this. Estimate Q1, Q3, and the IQR of the distribution. How would I find Q1? And we're talking about this same graph. Q1 represents what? Box and whisker plot. Yes. 25%. Awesome. So we're starting with the percent now. This represents 25%. So what does Q3 represent? 75%. So 25%. This time start on your percentages. This is about 30. So this is about 25. And someone who can see that, how many minutes is that? Good. So 25% is 13 minutes. That means that 25% of them are 13 minutes or less. And 75%, so start with your percentiles. 70, 75. Someone who can see, what do you guys think? 32, okay. And so what would the IQR be? Oops, 32 minus 13. 19 minutes. So IQR is Q3 minus Q1. All right. Now we're going to talk about z-scores. This is important for like the rest of the book. It's your first introduction to a z-score. How far above average was Brady's 86%? How far above? So we're going to measure things by standardizing everything. So you can standardize any kind of number on what's called a z-distribution. So a standardized score, or a z-score, has this lovely formula. And you should write down this formula and what it means. X is the data point that you're given, like the 86%. Mu sub x is the mean of the distribution. So what was the average on the test? Sigma sub x is the standard deviation of the distribution. So always do this, and you got to know this formula. The data point minus the mean divided by the standard deviation. So let's go back to this, and you got to find your data here. Here's the mean, 80. Here's the standard deviation, Okay, those are the only two numbers we need from all the data. And we're going to do the formula. So the z-score is equal to the data point, Brady's score of 86, minus the mean, which is 80, all divided by the standard deviation, which is 6.07. And that gives us 0.99. What does that mean? That means he was almost 1 standard deviation above the mean. All right, the day after receiving his stats test result of an 86 from Mrs. Weber, Brady earned an 82 on Miss Cannon's calc test. Brady. At first, he was disappointed. Then Miss Cannon told the class that the distribution of scores was fairly symmetric, with a mean of 76 and a standard deviation of 4. On which test did Brady perform better relative to the class? So this is where we standardize everything with different means and different standard deviations. So we're going to compare z-scores because they have different means and different standard deviations. So this time he got an 82, and I'm going to find the z-score, my data point. And we're subtracting the mean. Well, the mean in Miss Cannon's class was a 76, and the standard deviation was 4. And we get a z-score of 1.5. So on which test did Brady do better relative to the mean, you guys? Miss Cannon's. Even though he got a lower score, he's 1.5 above the mean, 1.5 standard deviations above the mean. So he did better in Miss Cannon's class relative to the average.